Hello and welcome to Robotics Surgery Insights. I'm excited to be joined today by Denis Gagnon, CEO at Belt Technologies Inc. Thanks for joining me today, Denis.
Glad to be here, Joseph.
Could you please start by telling us a bit about your own background, Denis, and introduce Belt Technologies Inc. to our audience?
Sure, I'd be happy to. So I'm generally a manufacturing guy. I've been doing that for over 30 years, whether starting as an auditor, CFO, private equity investor, and then eventually owner. This includes more recently with a family business, another global manufacturer called XL Dryer. And then about 5 years ago or so, I decided to go off on my own and had the opportunity to acquire Belt Technologies. So Belt Technologies is a U.S. manufacturer of stainless steel belts, pulleys, and conveyor systems and drive tapes that are sold to original equipment manufacturers around the world in some very high-tech industries such as robotics, automation, food processing, and of course medical devices. And what makes us, I'd say, or truly makes us unique is our ability to provide a customized solution, take a relatively simple thin piece of steel and turn it into a highly precise and engineered solution for a lot of very unique design challenges that our customers have.
And what would you say are some of the main benefits of using a stainless steel belt to your customers?
Sure, Joseph. Stainless steel belts have a number of advantages over other belting material types. First of all, the stainless steel is, of course, very strong and reliable, relatively speaking. So it's going to last, have a longer lifespan, result in less maintenance and changing the belts over time. The stainless steel belts are also inherently very clean. They don't outgas. They don't give off particles. They're very hygienic and easy to clean. This is important in an application such as food processing or semiconductors or a clean room environment, or let's say an operating room environment where hygiene is critical. They can also handle very, let's say, harsh environments that could usually be an extreme temperature, hot or cold. Maybe there's some kind of other chemical exposure. But generally speaking, these are very unique applications. And in fact, on that point, one of the key benefits of working with somebody like us is all these solutions are very customized. We're generally working with that design engineer for the original equipment manufacturer, and we're helping them solve a particular problem that they've run into with their design, where a stainless steel belt is going to be the solution that helps them get them over the hump. So that's a very critical feature, a very iterative process, an important part of the value proposition to help customize the solution. And then once we've come up with that design, now we have very skilled operators that have been building these types of belts for decades and can manufacture them to very, very tight tolerances, which that precision is certainly key and another advantage that we might have over other belting materials. And further to that point, our welding capability is especially, I'd say, what we do better than anybody worldwide is our ability to weld that very thin steel material, be able to weld it together endless, or as the case with a drive tape, weld an attachment onto it in a very reliable fashion.
And could you please explain why your products are so suitable for surgical robot applications?
Sure. So in the case of surgical robots, that strength and reliability is certainly key. Obviously, in an operating room environment, you can't afford a failure or an oops. So having that very strong, durable, reliable equipment or part is critical. The precision, of course, is extremely important. God knows what kind of, very tight tolerances you have to deal with when operating on a human tissue. But we're able to hold positional accuracy very well and over time, which is critical. There's also the avoidance of backlash in particular. So where you have the steel is not going to stretch over time, it's going to hold its position. And then also, especially working in tandem, so you have two belts push-pull, you're going to eliminate that backlash, so or what would translate into some kind of a wobble of that surgical robot arm, which of course can happen while it's inside of a patient on the table. The customization is certainly critical to the process as well, and in fact, for the surgical robot application specifically, we came up with one of our most advanced engineered designs, which is a multi-layered band. And the benefit of this is you have the kind of the best of both worlds in a way, where you have the reduced bending stresses of each individual thin band. And when you're wrapping the surgical robot might have very tight joints. And if you're trying to wrap a piece of steel around those tight joints, that bending stress is what's going to do the belt in. So by having multiple thin layers, you're reducing that stress and that risk, while at the same time, you benefit from the strength of all 6 layers working together. And I would be happy to demonstrate that point further to you. All right, so what I'm holding up to the camera, I think my shirt's maybe the best background, but you can see this is a individual band. If it's lying flat, you'll notice that the layers are going to buckle, and that's because the top layer is just a little bit longer than each succeeding layer below. So, which requires a lot of precision to put that together just right, so that now when you take the belt and bend it around the pulley, it all lines up just perfectly. And that's how that works, so that you're minimizing the bend stress, because that top layer is designed just for that specific radius to wrap around. And I'll try to give you a little better visual. Bear with me. So here you can see an actual, and this would be what it's like mounted on an actual robot. And I'd say the camera, you're not going to be able to see the layers anymore because they've all melded together just perfectly. And then, of course, I'll have to, reposition myself here. But now I'll demonstrate the movement is going to be very, very precise now in how it operates around that pulley. So normally, if you were to just make a band that was this thick, you would have all the stresses on the top of it, and it's going to want to pull itself apart. Where by splitting it into 6 and having different lengths to the layers, now you've alleviated that stress, but now you have the strength of that full thickness of the band. So this was a solution designed specifically for surgical robots, and allows them to handle potentially very heavy loads, but still keep that reliability while working in a very compact design that the engineers were after to fit in the operating room. The other, just another feature of how this works is usually use these belts in tandem. So there's one's pushing the one way, the other pulls back the other way. And what this does is it eliminates any backlash, which obviously if you're lying open on the operating table, you don't want to have any kind of wobble in those arms with the instruments that are inside working on you. So that's this solution with the 2 belts working in tandem should allow for that to occur.
Excellent. And what are some of the other medical applications that belt serves?
So there are a number of them. For example, we've been in manufacture of oncology scanners as a big user of our belts. Some very precise manufacturing of components for diabetes test kits. And then going back a few years, one of a longtime customers actually makes blood testing equipment. And so when COVID hit, they were one of the first to be out with a rapid COVID test. And needless to say, those were in very high demand, and we felt we were contributing to the cause in our way by prioritizing their production as it surged over that time to deal with the pandemic. And in addition to medical devices, we certainly do work with a number of high-tech industries across the board, whether drive tapes like I just demonstrated to you, or endless conveyor belts to actually convey a product. Again, very specialized for unique situations.
What is your view on the growth prospects for the surgical robotics industry?
Well, we certainly see there to be very good growth prospects for the surgical robotic industry. Primarily that's driven by labor shortages, as usually the case with automation. So that's in medical professionals, your nurses, your actual surgeons themselves. This is a way to help alleviate some of that strain in demand. Obviously, there can be, as great as many surgeons are, there's still a human factor, and there could be slips or wobbles in the hand dexterity. Obviously, using as just demonstrated, a very controlled robotic environment helps eliminate that potential error. And then you also have, it's always a goal to have consistent outcomes in the healthcare space. And this helps ensure it, rather than there being a wide range of outcomes depending on the surgeon or the location. This should help to make it more consistently precise, and a good outcome. And so in particular, what's helping drive it, certainly some of our customers are part of this, is having a more affordable product that some regions may not have the resources to otherwise afford this type of equipment. And as one of our customers put it, they're trying to democratize the surgical robot space so that anybody worldwide can benefit from these features. So we see there to be a lot of growth prospects, and we hope to be right there helping support it.
Excellent. And what advice might you give to a surgical robot design engineer who is considering your type of product?
Yeah, so I'd say the first thing that comes to mind is to contact us early and often. As mentioned, it's a very highly customized process. So our engineers and our sales engineers have decades of application experience. So if you're the original equipment manufacturer, it behooves you to work with us sooner. The sooner we get consulted or brought in, the more you might eliminate any possible design constraints that now we have to work with and try to work around, rather than from the beginning help you come up with the optimal solution.
And could you talk a little bit more about what a custom project looks like?
Yeah, so that customization is really a key component of what we do, and why you would come to us as the belting experts, as opposed to, there's plenty of other metal processing shops across our country and worldwide that can weld, they can cut, they can perforate a steel band, but they don't have the specific process knowledge of belting that might specifically apply. So we've been doing this for decades. And it's often an iterative process where we're working with the design engineer of the original equipment manufacturer. And there's always some kind of new, unique challenge that they need to try to address. And so working with us, it's not just, hey, give us a print and we'll cut it and we'll punch it and we'll weld it for you. But we're going to work with you to design, hey, what is the right material? What's the right perforation pattern as applicable? There's attachments that need to be welded to the belt, coatings perhaps that need to be applied. We know what we're capable of, and we've probably seen something similar before, so we can help you as the engineer design something we're gonna understand what it is specifically that you're up against, and then help you identify the perfect solution to fit that.
Thank you very much for your time today. It's been great talking with you.
My pleasure, Joseph.